let's talk about transformations today. Have you learned transformation in Algebra 1? Yeah, we use the same rule for Algebra 2, and we are going to use the same rule, transformations rule, in pre-calculus and calculus, okay? So it is so important. So master this time. Parent function of number 1, what is it? Y equals x squared. What does that mean, parent function? Make it simpler, okay? Don't take negative things, okay? Everything will be simplest way. That is called a parent function. Number 2, what is going to be a parent function of this? Y equals, keep the same operations, and then just keep it simple. Absolute value of x. What is going to be the parent function of number 3? Y equals x to the third power, cubic function. Question number 4, what will be the parent function? Y equals, don't worry about all the numbers, okay? Make it simpler with only the operation there. X to the second power. So number 1, number 4, both are quadratic functions, okay? Parent functions are same. And this is the child function, and this is another child function, okay? But it looks different way. This is called the standard form of writing, and this is vertex form of writing. So we have two different formats, but that will be the same kind, okay? Number 5, what is the parent function? Y equals x, linear function, degree 1, linear function. Number 6, y equals absolute value of x. Have you learned absolute value function in Algebra 1? Yep, V-shaped function, that's right. Okay, and then next page, number 7, what is the parent function of h of x? Y equals, don't worry about negatives, okay? Make it all positive with a simpler way. X to the second power, so this is also quadratic function in the vertex form. Number 8, parent function. Y equals absolute value of x. That's right. Now we need to look at the equation, and then we are going to identify what type of transformation is happening. Long time ago in elementary school, we learned about slide, flip, and turn. Do you remember those days? In middle school or in Algebra 1, we learned this in different language. Translate or reflect here. Instead of turn, what did we use? Rotation. That's right. So we are talking about the same things once again. If we slide, flip, turn, we keep the same images, and that is called isometry. Do you remember isometry from geometry class? Angles are same and lengths are same, so that keep the congruent shapes. But if I do dilation, in other words, stretch or shrink, and I will see the different measurements, right? So this doesn't keep all the angles or the measures on the length. So dilation will be a distortion of the shape. So all of these together, what is the big term? Transformation is a group word, okay? Talking about all of this. And now we need to understand this relation with an equation. By looking at the equation only, you need to be able to answer the transformations. So let's see all different numbers and signs on the equation, okay? Because of -1, what do I need to say? This is a vertical shift, or you can say translate where down 1 unit, okay? Alright, so let's graph. So parent function of x squared, quadratic function y equals x squared has points at 0, 0. 1 times 1 is 1, so 1 and 1. And 2 times 2 is 4, so another point is at 2 and 4. 1, 2, 1, 2, 3, 4. Since parabola, the graph of the quadratic function is symmetrical along the y-axis, even function, right? So I'm going to have the same location of those points on opposite direction. And then let's connect the points nice, smoothly, and this is going to be the parabola. This is my given parent function. 0, 0, 1 and 1, 2 and 4. And plot the points on the opposite direction. Flip the points along the y-axis and have another points and connect all 5 points. 3 points are enough, but 5 points we can have better graphs. And now let's talk about moving all these 5 points down 1 unit. Okay, vertex will be moved, and this point 1 down, and 2 and 4 1 down. So this will be at 2 and 3. Alright, the other points, move 1 point down, down, and then connect the points nice and smoothly. So this is going to be my new function g. So I need to label it g. So without calculator, I can graph if I understand the rules of transformations. So understanding transformation is very important for graphing and analyzing the functions. Question number 2. Let's draw an absolute value function. Absolute value function. Let me draw a straight line from corner to corner. Ooh, my corner is wrong. Okay, here. And the other one, corner to corner. Alright, 1 by 1, you connect the dots, right? Rise over run is 1 and 1 at the same time. 1 by 1. So you have absolute value function like this. So this is my parent function. Y equals absolute value of x. 1 up, 1 to the right. 1 up, 1 to the right. 1 up, 1 to the right. And the other side, 1 up, 1 to the left. 1 up, 1 to the left. And it was y equals x graph like this, but it is flipped because we have absolute value. That means think about only positive, okay? So we bent that part to the other parts. So this is a piecewise function. We have 2 parts of the graph, okay? 2 pieces. So what am I going to do with this parent function for the new guy? So let's talk about all the numbers on the equation. Because of 2, what do? Times 2, that means vertical stretch by scale factor 2. Scale factor is going to be always positive number, okay? Scale factor 2. And let's talk about number here. Because of number inside, what number do you see? You see negative 1, but in the format itself we have negative, so you think about opposite number, okay? You see negative 1 and give me 1. So this one is moving to the left, right, okay? Is it moving to the left or right? Give me only 1. 1 means to the right. What number was that? Negative 1. Don't give me left to 1, okay? You take away negative sign. In other words, change the number to opposite and then follow that sign. This graph will move to the right 1 unit. So let's graph. Move the vertex to the 1 unit to the right. And then let's go rise over run from this vertex. Instead of 1 by 1, we go up 2 and 1 to the right, because 2 times means it gets steeper, okay? So from the vertex, new location of the vertex is at 1, 0. And 2 up, 1 to the right. 2 up, 1 to the right, and 2 points up and 1 to the right. 2 up, 1 to the right. The other direction from the vertex, 2 up, 1 to the left. Repeat, 2 up, 1 to the left. Keep repeating, 2 up, 1 to the left, 2 up, 1 to the left. And then connect the points with a straight edge, and that's going to be your the child function f. So this is function f. Any questions so far? Alright, let's do one more graphing with me, okay? And transformations. So I need to talk about all different parts on the equation from the parent function. What is different? This negative, what does that mean, this negative? Flip, that is the meaning, okay? What is nice word saying flip? Reflect along x-axis, or you can say x-axis. You can say reflect about x-axis, reflect with respect to x-axis. What is different thing again to describe? Here, -2. Because of track 2, what happened to the parent function? Is it going to the left or right, or going up or down? It's going down. Translate down to units, okay? How do I know left to right or up or down? Number is in the parenthesis with x. It moves to the left to right. This number is not with parenthesis for x, so it's moving with y value, okay? So let's graph. Third one, parent function with the blue color. 0, 0, 1 times 1 times 1, 1. And 2 to the third power, 2 times 2 times 2 is at 8. So this is 10 by 10 grid, so this is 8. And opposite direction, since this is an odd function, and I'm going to have same location with the opposite direction. So -1 and -1, and -2 and -8. This is going to be a nice and smooth curve. And this function is keep increasing from left to right. Strictly increasing all the time. So this is y equals x to the third power cubic function. And my child function on this one is reflecting along x-axis. So I need to draw upside down first, and then move the graph down 2 units. Okay, so let's calculate the numbers. 0, 0, when you flip 0, 0, what do we get? Yeah, flip 0, 0, and it's still 0, 0. Move down this point 2 units. What is going to be the number? 0, -2, that's right. So 0 and -2, that is going to be the new point for that. And I have another point, 1 and 1. Think about flipping 1 and 1 upside down. Where does it go? 1 and -1, right? It was at 1 and 1. Flip upside down along the x-axis. It goes to 1 and -1. And bring this number down 2 units. Where does it go? 1 and -3. So 1 and -3. 1, 1, 2, 3. So that point goes there. Let's try one more point. What was the third point here? 2, 8. 2 times 2 times 2 was 8, right? If I flip this point, where does it go? 2, -8 upside down. 8 goes to -8 on the bottom. And then let's move down 2 units on this number. Where are we? 2 and -10. That's right. So 2 and -10 is going to be the new location for the point. And I'm going to draw a nice and smooth curve here. Okay? And what am I going to do with the opposite arm? Let's do the same way, okay? And you can do the same way, and I can use the symmetrical shape from that point, and then I can find the location. So that was here, and then it's going to be 2 down there. So this will be the point like this. Okay? Alright, so it moved down 2 units after you flip it. So knowing transformation is very, very important for graphing. Have you used the calculator for graphing here? No, we didn't. We know the relation on transformation from the equation. We can graph quickly. Okay?